Next problem, a radio link has a 20-watt transmitter, right? So 20-watt transmitter is given, 20-watt transmitter to an antenna, connected to an antenna at 2.5 meter square, effective aperture at 5 gigahertz. The receiving antenna has an effective aperture of 0.5 meter square, effective aperture of 0.5 meter square, and it is located at 15 kilometer, and it is located as 50 kilometer. So line of sight distance from the transmitting antenna, assuming lossless matched antenna, find the power delivered to the receiver, right? So you are asked to find the power delivered to the receiver antenna, that means the power is received, right? According to the Freese formula, you got to calculate this this expression to calculate the received power. So you can write all the given parameters. PT is equal to 20 watt, A is equal to 2.5, and F is equal to 5 gigahertz, and the effective area is 0.5, right? So effective area, the distance is 0.5. So if you substitute all the values given here, you will be getting the received power is equal to 30 point, it is not shown in this slide, 30.86 micro watt, right? So this is the answer for the problem. The next problem, an earth station with a transmitting power of 120 watt, a frequency of 6 gigahertz, and an antenna gain of 42 dB, transmit to a radiation repeater. The receiver antenna on the satellite has a gain of 31 dB, right? So receiver antenna gain is 31 dB, and the satellite is in synchronous with 35,900 kilometer, the distance above the earth station. What is the received power? So you are asked to calculate the PR, right? So again you have to use the Freese formula to calculate the power. So here the GT and GR 42 dB and 31 dB is given in decibel. So first you have to convert that into statistical value by taking the anti-log. So how to take? So you know the formula, that is 10 log GT, right? So 10 log GT equal to in G in dB, right? So it is given. What is given? It is given as 42 dB, right? 42 dB. So what you have to find? So you have to first take 42 divided by 10, then you have to take anti-log. So in order to calculate the statistical value of the GT. Similarly, you have to calculate the statistical value of G, that is received gain also. So after calculating that, by using this given value 6 gigahertz, it is given, frequency is given. So F is equal to C by lambda, F is equal to 3 by lambda, lambda is equal to C by F. By using that lambda, you can able to calculate here. Then substituting all the values, you will be getting the PR value equal to, PR is equal to minus 75.3 dB m, 75.35 dBm, or the received power PR equal to, in statistical value, it is equal to 2.94 into 10 power minus 11 watt. This you can convert into dBm by having, what you have to go? So convert value to dBm. What you have to do? So to convert dBm, you have to take dB means you have to take log. If it is dBm, so whatever the value, that should be divided by 1 milliwatt, right? So 10 log of whatever the value divided by 1 into 10 power minus 3, right? So this is a formula, you have to use it for convert the watt into dBm value. The next problem, this is given here, right? So this is a value, it is given, right? So like that. So the value divided by 1 into 10 power 3. The next value, next problem, what is the maximum effective aperture of the microwave antenna having, what is the maximum effective aperture of the microwave antenna having 360 degree, 30 degree and 35 degree in perpendicular plane intersecting the axis, right? So actually this is yeah, this is the 9th problem, I think so, right? So there is no 18th problem. What is so the 19th problem? What is the maximum effective aperture of the microwave antenna having the directivity of 900? That's all, right? So the formula, direct formula, 4 pi AEM divided by the lambda square. So here, since the f value we don't know, it is not given, so the answer can be in terms of lambda, right? So just you can substitute the value of d, it is only the given value. Substitute and simplify, you will be getting the effective aperture is equal to 71.6 lambda square. The last problem, the two spacecraft are separated by the separated by 100 kilometers, separated by 100 kilometers. So the distance of separation, it is given as 100 kilometer. So then each has an antenna with the d is equal to 1000 operating at 2.5 gigahertz. If the craft A is received over 1 picowatt, what transmitter power is used on craft B to achieve this signal? That is clear. So lambda is equal to C by F, you know the formula. So by substituting the given value of 2.5 gigahertz, you can able to calculate the lambda value. Then you can able to calculate the effective aperture because D is given. So D is given and lambda just you have calculated. Substituting these two, you will be getting the value of effective aperture, right? So here, so PT you know that is equal to PR r square divided into lambda square divided by AE square. So AE the formula it is given. So if you substitute the formula for AE here and rewrite, you will be getting the formula for the received power is like that. Then in this you can substitute the value of the given values d, lambda, extra. You will be getting the value of the received power. The P r is equal to 11 kilowatts.